Hi Gemma. So for question 16a from review exercise 3, pure year 1, we are told a company makes solid cylinders of variable radius r and constant volume 128 pi centimeters cubed. We've been asked to show that the surface area of the cylinder S is given by the following equation. Okay. So the first thing I'm going to do here is I'm going to look at how to find the volume of a cylinder. Okay, so you should know that the volume of a cylinder is equal to the area of the cross section, which is pi r squared times by the height h. Okay, so I'm just going to write that again here. We know the volume, we've been told it in the question, so we can say that that is equal to 128 pi. Okay, so now we're going to have a look at the surface area of a cylinder. So again, you should know that the standard formula for the surface area of a cylinder is given by the following equation. So I'm going to write it out again here. S Okay, so if you're not familiar with this formula, go along to examsolutions.com and I'll have a video describing how this formula works, okay? So let's have a look at our formula for the surface area of a cylinder and what we've been asked to show. What's the difference? 2 pi r term is exactly the same. The only thing that's different is the first term here. Okay, we have h and they do not. So what we're going to have to do is we're going to have to eliminate h from this equation, okay? And we can do that using this equation here. Okay, so and I'm going to divide both sides by pi r squared. So you should get h equals 128 pi over pi r squared. Okay. Now pi divided by pi is simply 1 over 1. So we know that h is simply equal to 128 over r squared. Okay. And now we're just going to substitute that in here. Okay, so S surface area is equal to 2 pi r, and now we know what h is. H is 128 over r squared plus 2 pi r squared. Okay, so now if we just expand this bracket, and you should realize as well that r's cancel. Okay, so we're just left with r on the bottom. So we're just left with S equals 2 times 128 is 256 pi over r plus 2 pi r squared. Okay, so we've shown that to be true.